Hello everyone and welcome to this new Inventor 2019 video tutorial. So we've firstly seen how the interface works. We've modeled a piston, a connecting rod, and today we will be modeling a crankshaft. So as usual, I'm going to open a new document. So it's going to be a standard mill IPT, and I'll click on create. I will now start a new sketch on my XY plane, and I'll start by creating a few parameters. So I'll go on add numeric. I'll call my first one center shaft DIA of diameter. My equation is going to be 52 mil, so 52, enter. I'm going to create another numeric parameter. It's going to be called stroke. I will give it a value of 35 mil, press enter. I will add another numeric. I will call it conrod dia. I will make it 52 mil as well. I will add another numeric. This one I'll call it hole. It will be 8 mil. I will add another numeric. This one I'll call it balance with, oops, spelled wrong, and there we go. And that will be 15 mil. I will add another parameter. I will call this balance spacing. I'll make it 40 mil. I'll add another numeric parameter. I'll call it spacing and make it 100 mil. I will create another one, call it flange DIA, and make it 120 mil. And my last one will be flange width, and I will make it 20 mil. So I'll click on done, and I will start with my sketching. So the first thing that I will do, I will create a circle. So I'll use Ctrl+Shift+C to draw a circle, or click on circle. My circle is going to be a ladder dimension now. I'll go to my parameters, list parameters, and now I know that that's my center shaft diameter, and accept it. I am now going to create another circle, and my dimension, I'm going to dimension it, and this one is going to be, I'm going to go my list parameter, and this is going to be my conrod diameter. So I just realized the diameter for our conrod was 48, so I'll go back to my parameters, conrod diameter, and I'll make that 48. So I'll click on done. Now if you realize our center is not vertically aligned, so I'll hold Control, right click, vertical, and I'll click on the center and center, so it's vertically aligned. I will now add another dimension here, and I will go my list parameters, and that should be stroke. So that's done for now. I will now draw a circle that is going to be 120 mil diameter, and another circle here that's going to be 67 mil diameter. I'm now going to enter a function, and I'm going to call this conrod dia with my C capital, which is my list parameter, but I don't want it to be equal to my conrod diameter. I want it to be always plus 15 mil. So I'll press enter. So then that means that this will always be 15 mil bigger. Maybe I'll make it 19 instead. So I'll make it 19. The next thing that I'm going to do, I am going to draw a line that goes from here up to here roughly, and up to this second circle. I'll hit escape. So I will now apply a tangent constraint between this line and this circle. So my line is now tangent, and I will make sure I will make an angle between these two lines. So that angle will be 120 degrees. And now I'll edit the length of this line, the real length, not the height. So right now it's pulling the horizontal length, but if you left click again on it, you'll pull the real length. So now I'll make it 22. So that's exactly what I was after. So I will now draw another line going across the center. I will select it, right click, and turn it into a construction line, and I will now lock it. So now I'm going to mirror these two entities. Select my mirror line and click on it. Click on apply. It's done. Now I will use my trim command, and I will trim these two lines here, this line, this line, this line, this line, and these two. So you should have this on your drawing. So we can now redimension it. So I'll give this a dimension. I'll give this a dimension as well. Make sure that this is tangent. That's tangent already. And we need to know the distance, probably from the center to this line. So before I close the sketch, I'm going to open up my parameters, and make sure that my sketch actually works. So I will add the equation back again here. So I wanted my diameter rather than my radius. Let's find what I will do. I will make that con rod diameter divided by 2 plus 8.5. I think that should be right. I think it should be 9.5. Yes, 9.5. So I'll accept it. I'll open up my parameters and I'll make sure that my sketch works. So if I change my center shaft diameter here, if I make it 42 and press enter, I can edit it, so I'll make it 52 again. I can also change my stroke, so if I say that my stroke is 55 instead of 35, it works as well. I can also change the con rod diameter, so it's 48, if I make it 68, still works. And I will now close it. I can now finish the sketch and start with the 3D modeling. So I'm going to start by extruding this feature here in the opposite direction. My parameter is going to be balance spacing, which is here, and click on OK. So now I'm going to go back to my extrusion, find the sketch, right click on it, turn the visibility back on so we can see it. I am now going to start a 2D sketch on my YZ plane. I'm going to use my slice graphics, project cut edges, and now I'm going to place a point here, and I'm going to use a vertical constraint to constrain it to the center of this line, and a horizontal constraint to constrain it to the center of this line. So having my point positioned, I'm now going to use the hold command and I will try to find my point, which is there. And now here I'm going to use list parameters and whole. And for termination, I'll say through all in both directions, symmetric. So that should work. I'll click on OK. I will now use a fillet, apply a fillet here and here, probably 0.5 of a mil, and click on apply. So that's my hole now done. I will now proceed to extrude my balance. So it will be this and this, and I'll go my list parameters and select balance width. Click on OK. So that's done now. I will now start a 2D sketch of my YZ plane and use my slice graphics, project cut edges, and now I'll draw an arc from here to here. So now I can use a dimension from this line to this point. So that's going to be, I think, yes, I added this this constraint by accident, this coincident constraint. So I'll apply a dimension now from there to there, make it 6 mil, and do the same with this end. So I'll say from this point to this point, that should be 20 mil. And now the radius of this will be 160 mil. I'll finish my sketch, and now I will use my split tool, trim solid, and select my trim tool and switch the direction and click on apply. So that's now trimmed. I'll close it. I will now apply a chamfer. I will use the third option, 2 distances. The first one will be 20 mil and the second one will be 11 mil. And I will select only this edge, so you can see here. So I'll click on apply. Close it. I will now use a fillet, 40 mil, and apply it to this edge and this edge. And click on apply. It's a bit too big, so I'll try a smaller number. I'll try 35. Seems to work fine, so I'll apply it. And now I will fillet everything else to 1 mil. So I'll select loop. So this would keep everything filleted now. So I will accept it, click on apply and close it. Okay, so the next thing that I will be doing is I will be creating a plane. First I will right click on my sketch and turn the visibility off. I will do the same. It's fine, all of my sketches are actually off, so I'll go on plane, select mid plane between two planes, select this plane, and now we'll use my mirror tool, and now I'm going to mirror my everything from extrusion tool, so I'll select this, and now I'll scroll up to fillet 3, hold shift, left click. Now I'm going to select my mirror plane, which is this plane, and I'm going to click OK. So we have our balance on the opposite side as well. Now I can right click on my work plane and turn the visibility off. I will now create another sketch on my work plane 1. I will slice graphics. I will now use my project cut edges, and now I'm going to draw a circle around here, make it 15mm diameter. I'm going to apply a vertical constraint between both centers, and I'm going to apply a dimension between both of them. So the distance is going to be 50mm. I'll finish my sketch, and I will now extrude that circle in both directions. I'll delete the parameter here, and I'll say through all and cut. So I cut the hole all the way through. So I'll click on OK, and I will now use a fillet and fillet both of these edges and click on apply. So I can now close this menu and proceed. I am now going to start a 2D sketch on this face. I'm going to slice graphics, and I'm going to draw a circle right at the center. I will now dimension it, and I'm going to use one of my list parameters. So in this case it's going to be center shaft diameter. I'm going to finish the sketch, and now I'm going to extrude it on the opposite direction, not cut, join. And it's going to be my spacing divided by 1.535, and click on OK. I am now going to start another 2D sketch on this plane. I will use my slice graphics again, project cut edges, and I'm going to draw a point around here, and I will now use a horizontal constraint to the midpoint, and actually I will cancel that one I'd rather enter a dimension in this case, so I will use a vertical with the center, and I will use a dimension. So I'll say from the dimension from here to this corner, that should be 20. And I will finish my sketch. So I'll now use my hole command, select it. So it has already selected my parameter, which is hole. I'll click on OK, and I will now apply another fillet here and here, which should be 0.5 of a mil, and click on apply. So I think we've done the hardest part so far. So the rest should all be a little bit easier. So I'm now going to use a rectangular pattern. Before I do, I'm going to edit my spacing and make it 110 mil. Now I'll click on done. Now I'll use a rectangular pattern. I will select everything I've got, so from extrusion up to fillet, so hold shift, click on the first one and click on the last one. Now I'm going to select my direction one, so click on this arrow. Actually, before you do that, what we're doing, we're trying to pattern individual features when we actually want to pattern solids. So I click on the second option, and now instead of join, we're going to create new bodies. So it's going to pattern all of these, creating 4 equal bodies. So in direction one, click on this arrow. I'm going to click on this line, which Inventor will use as a vector for plotting all of this. Now we'll select 4 units, and here I'll type in spacing. And I'll click on OK. There is something slightly wrong, so we can edit this bit. If we go to extrusion number 4 here on your model tree, we're using a function spacing divided by 1.5. So if we say spacing divided by 1.6, that should work out. So that's fine now. That's all solved. And okay, so when we did our rectangular pattern, and we chose not to pattern individual features, because otherwise it would join all of this into the same object. So all of this would be an unit now. Whereas if you go on your model tree and you go on solid bodies, if you expand it, you can see solid 1, 2, 3, 4. So they're all separately, so we can now play with them. So what I'm going to do next, I'm going to go on, I think it's under modify, so under the modify tab here, and I'm going to go on move bodies. So I'm going to select, I'm going to click here, and I'm going to switch from free drag to rotate about line. So I'm going to select, I'm going to click on bodies, select solid number 2, and here I'm going to select my angle, which is going to be 180 degrees, and my rotation axis, which I can select this one for instance. So that should be correct. So I'm going to go on apply. Now I will do the same. I will expand this tab, go on rotate about line, select my body, solid number 4, 180 degrees. My rotation line is going to be the center shaft, and click on apply. And now we can close it. So we're doing a V8, so that's why the 180 offset. So there will be 2 con rods going on each one of these. So I'm now going to start a 2D sketch on this face. Draw a circle. So I will give it a dimension and call that as well list parameters, center shaft diameter, finish sketch, and I'm going to extrude it by 6.25 mil, just to make it slightly longer. I'm now going to sketch again on the same face, and this circle is going to be 120 mil. I'll check my parameters. So that can be flange diameter. We created a parameter for it earlier, so we'll use it. Now finish sketch, I will go on extrude, and for my extrusion I'll go again on list parameters, and there will be flange width, and click on OK. So I'm now going to start another sketch here. Going to draw another circle. This one is going to be 56 mil. I'm going to finish it, and I'm going to extrude this cut by 5 mil. Click on OK, and now I'm going to chamfer this edge. So I'm going to go on an even chamfer, maybe 2 mil, and I'm going to click on apply. I'll actually edit that chamfer, and instead I'm going to make it 3 mil, and I'm also going to add this edge on top, and I'm going to click on OK. So the next thing that we'll be doing, I'll be starting another sketch on this face, and I'm going to place a point. I will now project my cut edges. I'm going to use a vertical constraint to place this point vertically, and I'm going to place a dimension between the two, and I'm going to make it 42.5. I'll go on finish sketch. Actually, before I finish the sketch, I'm going to use a circular pattern. So I'm going to select this point. I'm going to select this circle or this circle as an axis. And I'm going to enter 8. I want 8 circles. So I'm going to click on OK. Now I'm going to use the hole command again after I finish the sketch. So I'm going to go on hole. Inventor has already found my hole, so I'm going to use countersunk. So I'm going to select I'm going to go on placement, position 7 selected, size, I will go on termination, so I'll say 2 and select the surface. I'll close it and open it again. I'm going to keep it simple and just use normal holes. I'm just going to change the termination and say 2 and select this surface. And I'm going to click on OK. I'm now going to sketch. I may actually don't need to sketch. I may still have my original sketch, so I'm going to use it. I'll turn it on, so I'll go on my model tree to extrusion 1, right click on it, turn the visibility on, and now I'm going to go to extrude. I'm going to extrude this circle by 54.5 mil in the opposite direction. For some reason it's not working. I'll try again. Oh, the reason why it's not working is because I haven't selected the solid. So I'll show you what's been happening. So we have solid 1, solid 2, 3, 4. And now if we want to extrude this, we have to tell Inventor what solid we want to use. So I'll click on solids. We want this to be part of solid 1. And now it should be able to work. So I'll click on OK. So that's done now. I will now start another sketch on this face. I'm going to draw a circle. It's going to be 45 mil diameter. And I'm going to finish my sketch and I'm going to extrude it by 16.5 mil. Click on OK. I am going to start another sketch on this face, but this time we're going to draw a rectangle. So I'm going to use project cut edges and I'm going to draw a 2-point center rectangle. So it's going to be 33.5 by 30. I'm going to finish the sketch and I'm going to extrude it by 43.5 mil. Now I'm going to click on OK. So I should now be able to fillet it. So I'm going to start a fillet and I will make a 10 mil radius and I'll fillet all of these 4 edges. And click on apply. I will start another sketch on this face. I'm going to draw a circle. From the center it's going to be 26 mil. I'm going to finish the sketch and now I'm going to extrude it by 15 mil. So I'm going to type in 15. We can now add a chamfer. So our chamfer is going to be 3 mil. And now we can chamfer this edge, and this edge. I'm going to click on apply. And now I'm going to create another extrusion. I'm going to make this start to the sketch here. I'm going to draw a circle. It's going to be 8 mil diameter. I'm going to finish a sketch and I'm going to extrude it by 10 mil. And I'm going to click on OK. And I'm going to add another small chamfer for this edge. It's going to be 1 mil. And I'll click on OK. So the next thing that we'll be doing, I'll turn off my sketch. The visibility is now off. I will now add a few fillets. So I'm going to add a 1 mil fillet, should do, maybe 2 mil. 2 is too much, so I'll leave it as 1. And I'll fillet all of these corners. It's not letting me select this one. Maybe it's because I haven't chosen the solid. So I may be able to add it now. No. Before I add the fillets, I'm going to cancel it. I'm going to join all of this. So I'm going to use the tool combine. So I'm going to combine all of these solids in one. So I've just selected them and I'm going to click on apply. So now I have one single solid and all of them are united. You can always undo all of these by going on the model tree and cancelling it. So I'm going to go click on fillet and I'm going to select I'm able to actually apply all the fillets now, so it's great. And I'm going to click on apply. So that looks like my crankshaft is now done. I can change the style a little bit. So I can, for instance, make my whole crankshaft maybe a steel cast. And then I can now maybe select my filter, and then select face and edges, and then maybe make all of these something else, like maybe can select the features instead, and change them to Chrome. So I have changed the material and color of my crankshaft. So this is entirely your choice how you wish to present it. You can also, if you go on the view tab, I've changed my style to realistic. You can add shadows if you wish. You can add reflections as well. Switch it from orthographic to perspective. I'll take my shadows away actually. You can even take a render. So if you go on ray tracing, now you can select the quality. That you're expecting to get off the render, whether low, draft or high. And the Inventor will take a photorealistic rendering of your part. So this is what came out after a few minutes of rendering. I didn't leave it until the end, so it's not too bad considering that Inventor is not the best rendering engine. So for the amount of time, the result is acceptable. So this will be it for this tutorial. So